In the bustling heart of a metropolis or the intricate lines of code, order matters. A single broken window, a seemingly insignificant crack in the facade, can quickly unravel the fabric of a system. This is the central premise of the broken windows theory, and it holds surprisingly relevant implications for the burgeoning field of artificial intelligence. Just as a neglected building invites vandalism, a poorly maintained AI system, riddled with biases or errors, can lead to significant, even catastrophic consequences. This essay explores the parallels between the broken windows theory and the development of AI, emphasizing the importance of addressing small issues before they escalate into larger problems. We will delve into real-world examples of AI failures stemming from overlooked flaws and discuss proactive measures developers can take to ensure their creations remain robust, ethical, and beneficial for all. By understanding the interconnectedness of seemingly minor issues and their potential to snowball into significant problems, we can foster a future where AI technologies are developed and deployed responsibly. This is not just about fixing lines of code, it's about building a better future. A future where AI systems are not just powerful but also fair, equitable, and worthy of our trust. The broken windows theory, popularized by James Q. Wilson and George Kelling in the 1980s, argues that visible signs of crime and disorder, such as vandalism or littering, can create an environment that encourages further lawlessness. This theory transformed policing strategies, emphasizing the importance of addressing minor offenses to prevent more serious crimes. The core principle of this theory, that neglecting small problems can lead to larger ones, transcends the realm of urban planning and resonates deeply with the development of AI. Just as a broken window signals neglect and invites further disorder in a neighborhood, minor flaws within AI algorithms, if left unaddressed, can escalate into significant ethical and functional issues. These broken windows in AI can take many forms. They might manifest as biases in algorithms used for loan applications, leading to discriminatory outcomes. They could be subtle errors in facial recognition software, resulting in wrongful arrests. Or, they could be vulnerabilities in autonomous vehicle systems, potentially causing accidents. Just as a city cannot afford to ignore broken windows, we cannot turn a blind eye to the seemingly small flaws within our AI systems. By understanding the potential consequences of neglecting these broken windows in the digital realm, we can begin to develop more robust and ethical AI solutions. Imagine a seemingly harmless AI-powered chatbot designed for customer service. Initially, it functions well, answering basic queries and resolving simple issues. However, a small coding error causes it to occasionally misunderstand requests, leading to slightly inaccurate responses. While these initial errors might seem trivial, they can have a cascading effect. As the chatbot interacts with more users, the flawed code generates increasingly inaccurate outputs. The chatbot's responses become less reliable, leading to customer frustration and a decline in trust. This erosion of trust can damage the company's reputation, ultimately impacting its bottom line. This hypothetical scenario illustrates how a seemingly insignificant broken window in AI can quickly escalate into a much larger problem. The initial error, if left unaddressed, multiplies with each interaction, eroding the system's effectiveness and undermining its intended purpose. This principle applies across various AI applications. A minor bias in a hiring algorithm can perpetuate and amplify existing inequalities in the workplace. A small error in a medical diagnosis system can lead to misdiagnoses and improper treatment. The interconnected nature of AI systems means that even seemingly isolated flaws can have far-reaching consequences. Addressing these broken windows is not merely about fixing technical glitches, it's about ensuring that AI develops responsibly and ethically, benefiting society as a whole. Case study: when AI bias turns deadly, the dangers of neglect. The tragic case of the self-driving car accident in 2018 serves as a stark reminder of the potential consequences when broken windows in AI are ignored. While multiple factors contributed to the accident, a key issue was the failure of the car's AI system to correctly identify a pedestrian crossing the street. Investigations revealed that the AI system had difficulty recognizing pedestrians in certain situations, particularly those not conforming to typical pedestrian behavior. This broken window, a bias in the training data, had fatal consequences. This incident underscores the critical importance of addressing biases in AI systems, especially those with life-or-death implications. These biases, often subtle and difficult to detect, can stem from various sources, including incomplete datasets or unconscious biases held by the developers themselves. The consequences of ignoring these broken windows in AI can be severe, ranging from perpetuating societal inequalities to causing real-world harm. Addressing them requires a multifaceted approach, encompassing rigorous testing, diverse training data, and a commitment to ethical AI development practices. The perils of ignoring broken windows in AI. Ignoring broken windows in AI is akin to allowing cracks to spread unchecked in a bridge's foundation. Eventually, the entire structure will crumble. The consequences of neglecting these seemingly minor flaws can be far-reaching and devastating. First, erosion of trust. As AI systems become more prevalent in our lives, even minor errors can erode public trust. This lack of trust can hinder the adoption of beneficial AI technologies, slowing down progress in crucial fields like healthcare and education. Second, exacerbation of inequalities. Biases in AI systems can perpetuate and even amplify existing societal inequalities. From discriminatory loan approvals to biased hiring practices, neglecting these broken windows can have profound social and economic ramifications. Third, loss of control. As AI systems become more complex, understanding their decision-making processes becomes increasingly challenging. Unchecked errors and biases can create unpredictable and potentially harmful outcomes, ultimately undermining human control over these powerful technologies. The stakes are high. We are at a critical juncture in the development and deployment of AI, and the choices we make today will have lasting consequences. Addressing broken windows is not just a technical imperative, it is a moral and societal one.